Good afternoon, everyone. My name is Colin Maposa, Solutions Architect from Huawei. So basically, I'll take you through the solutions that we have in the industry. With it, I would like to first to highlight why we are all here. I think you all gonna agree with me if I say data is the new oil. Do we agree? Okay. With it, now coming to say data is the new oil, it has to be protected wherever it is. We have to access it anytime, anyway. And as times have been moving with the digital transformation, we've been pushed to come with the solutions that makes us access that data as fast as we can. Now we're talking about AI, we're talking about all the new technologies that is out there, the new workloads which consume a lot of power and so on. But now, first of all, I would like to highlight where Huawei is sitting when it comes to this. And firstly, is to say, with the numbers on the screen, Huawei has been investing a lot. As you can see, up to 8,000 R&D engineers have been invested on. That is the research and development. And coming to the customers, we're serving up to 25 plus thousand customers, and also with the 3.2 patents that are there. And the last part is to highlight, like to say, we have about 12 research and development centers that are there worldwide. And with the recognitions that are there, Huawei has been number 2 on the global storage, and then coming to the A leader when it comes to the Gartner Magic Quadrant. And we also have, as you can see with the one from since 2006, it has been nominated to be one of the customer's choice when it comes to the on-premise system. So this is where the highlight of it, where to say where Huawei sits. And moving forward, we know what we're going through nowadays when it comes to the data centers, how we have to manage our data. There are different types of data that is out there. And coming to the new era of it, we are sitting where it's called flash to anything. Initially, it was disk to tape, but those are all days of it. Now we have to access the data on with the requirements that are there. We are sitting on the flash to anything, and anything can be cloud, can be a private cloud, can be an archiving system that you can have. But as you can see from the portfolio that we have, it's giving you the end-to-end solution coming from your production side, having the AI-ready storage, AI primary storages, which is your Ocean Store Dorado, extending it to the Ocean Pacific. And then now we're extending the backup where you utilize the Ocean Protect. And then the Ocean Protect with it, it's a dedicated backup storage for it, which comes with the embedded software for backup. And lastly is to mention the HPC, where we are talking about the Ocean disk that comes with the intelligence embedded onto those disks. So the whole portfolio of it, as you can see, you can scale out also to the storage, scale out storage, and then extend it to the backup. We've been talking about power, and when it comes to the consumption now, we are sitting at an era where you can utilize or have petabytes in the 2U form factors, and that is utilizing the small palm drives and reducing the total cost of ownership, the power for cooling, and so on. So this is mainly the whole portfolio of it, which comes in to say it helps the customers reduce the total cost of ownership, and also when it comes to the management on your data centers. So now we're talking about big numbers when it comes to data. Now we're sitting on the about 24 exabyte, and with it we generate data every day as we go, and all those applications are demanding. When we're talking about AI with it, it's depending on the data that you have. So we have to make sure it's sitting where it's optimum and it can be processed as quickly as you can. So this is mainly the use cases of what other industries are contributing when it comes to the oceans, to the storage. Now, highlighting the HPC challenges that are out there, we're taking it back to say where we come from. Since 1946, that is where we're sitting on about 5,000 flops. But now we are on the era when it comes to 2023, we are generating about petaflops, that is 1,194. So this is the growth where we were sitting at, and all these compute, they need performance. All right. Initially, with the HPC, all the system, the computing was being ran parallel. But now, as mentioning with the AI and the big data analytics that is out there, this has been integrated into one way to say now we have to have like the pools where you can generate that data from. But now extensively, like is to say where we are going to the data productivity center, where centric, where to say every endpoints, they depend on that data, they pull the data out of it to make the most out of it and give you that unified data lake. So this is the future of where we are going to say the future pulling data to what, to the product materials. And IoT also comes into play into that industry. And now highlighting the pain points and the challenges that we are facing in this new era is to say, one of it, we have the data mobility. Data sits everywhere nowadays. For us to access it, it has to be anywhere, and we have access to it anytime. So with it, those are the challenges, like to say, how do we move that data across different platforms? And that's one of the challenges. And then coming to performance. Performance comes from the hardware, the platforms that we are running on, and with them, there are different hardwares that are dedicated to give you that optimum performance. Like for example, mentioning the flash to anything. We're talking about the old flash systems that use SSDs, and then now we're talking about the NVMe that are out there. And then the other pain point is the total cost of ownership. We're taking it from the infrastructure, having a data center, and so on, and way to say there's power to cool that. So with those challenges, there have to be some solutions to what, to cater to mitigate all that. So now this is where you reduce the footprint and the silos on your data center. And coming to that data management also, there are different platforms to access and manage that data that is giving you your operations and management. So now you can utilize the cloud-based solutions that can help you manage your data across all your environment, depending on geographic locations and so on, since the data is now everywhere. And then coming to highlight the security and reliability, this is when also we have to highlight the high availability from hardware itself and extending it. For example, when it comes to the disaster recoveries and so on, you have to apply security onto that data, make sure it's protected. And operations and management, that is having different clusters deployed in different locations, and how we can monitor and manage that. That poses so much complexity onto your environment. So that can be simplified. And lastly is the computing island. And that is now we're talking about different locations and also the resources that can be deployed in different or positioned to an area where it's needed the most. So mainly those are the highlights of the pain points of challenges that are out there. And then now coming to how Huawei has the solution for it. This is a unified architecture hardware that we have. We have the A800 and also the A310, which is basically the entry level. So these are dedicated hardware which are meant for your big data analytics, AI, and also when it comes to uh, all the data acceleration. So with them, they come with the dedicated GPUs that are there, and then to give you that high performance, highlighting the InfiniBand network, and then also coming to all the sectors where you can position it. That is like on your foundation industry specific models that you can deploy it. And mentioning the pain points which I previously mentioned, with Huawei there's a full stack of it, where to say you can manage or use different tools to manage your data. That is having your data management using the DME, and then also when it comes to the data processing, utilizing the eDataMet, and then drilling down to your storage, where you can have like the A800 and then the A310, and also you can use the third-party storage. That means it can integrate with other vendors that are out there, the storage vendors. So it's not basically limited to Huawei only, but also other storage vendors can be used. So with it, it gives you an increase on your global data management, and then giving you that efficiency and performance in your data center. And also you having your full AI process acceleration, which gives you like for your hybrid workloads. Okay. And then this is just the breakdown for the A310, what it comes with. The highlight of it also is the DCS, which is a virtualization software that is embedded with it. It helps you like to deploy different clusters with the nodes, and that is basically the data center solution. And drilling down, that is the network which we are pushing the bandwidth 400 gig per second on the bandwidth. And also you can deploy up to 4,000 nodes. That is on the scale out expansion. Okay. All right, for the A800, which is a mid-range, with it gives you the AI high performance, and it comes with a unified for the NAS or flash storage. And with them, you can have an active solution. So when it comes to the active solution, this is when it gives you that high availability on your region, like to say, you don't have the downtime, and then it's giving you the full always online. And we are achieving up to 24 million IOPS, and also with a speed of 500 gigs per second. And lastly, it's about 36,000 T-flops, and yeah. Now, with the whole architecture of the GPU pass-through, as you can see the comparison from before, this is from the left side, that is the traditional GPU access. But how do we achieve that performance? With it, we utilize the output path of the GPU pass-through, which helps to boost or give you that performance, reducing the performance bottlenecks, and also scaling down to most of the ecosystem is basically accessed through the Cuba program modeling. And that's the pass-through solution of it. And then also now with the multipathing, with it, it helps to distribute the performance, giving you that optimum performance when it comes to accessing the data. That is basically. You say? Yeah, so on the background with it, it will be interconnected to say it gives you the access directly without having to pass through the switches. So it's directly integrated, basically. Okay. Okay, and then that's the highlight of the NFS multipathing, also giving you the full access, the redundancy when it comes to accessing and giving you that, and also it gives you like the 0 point of fail. Okay, and highlight of also the single stream and the single client, that is basically also more or less like to say you access all the storage nodes are simple, and also we're having one client which connects into multiple storage nodes. Okay. So with it, this has improved the full process of the efficiency when it comes to it, and giving you that optimum performance. That is now coming to the data tiering, that is also highlighted, and you have all your data that can be moved across your ocean store, that is your ocean store storage, and also you can use for any different types of data, that is drilling down to image, video, text, and other files, and so on. Okay. Right. So this is the Huawei solution for the Ocean Store Pacific series, which can be positioned on your archive, and also for mainly like when it comes to the intensive performance, and you have the intelligence tiering in between your data storages, that is giving you positioning it on the performance type, that is the production side, I would say, and then capacity type, that is now we're talking about where you can archive to, and so on. But it can have that intelligence in between where the data mobility comes into play. It can be moved across where it can be sitting optimum. For example, like now we're talking about autonomous driving. With them, it generates a lot of data, and with it you can have the hot data on your performance type and still replicate it to be sitting on your capacity type. So that's the flexibility of using the Ocean Store Pacific. Okay. And then also this is highlight of the NERs across the architecture to say, for example, the scientific research computing, the data can be tiered amongst different models, and also allowing to use different protocols. That is now highlighting the S3, where you can use the data archiving, and then which is mainly cost sensitive to it. Because nowadays you generate a lot of data, and with it consumes a lot of capacity, and you can utilize that. And that's giving you the hybrid workload oriented moving data. That is for the data mobility. And we've been now talking about all flash, and with it, we get optimum performance when it comes to the SSDs compared to the HDDs. And now with them, they are efficient enough to a point you can achieve petabytes in a 2U. You can reduce your data center footprint and also get that optimum performance out of lower capacity that you have. And you need less cooling when it comes to that. And that is the highlight of the Ocean Pacific 9920, where you can use it for your all flash and getting up to all that large capacity when it comes to the usable capacity. And then there's a low footprint when it comes to green and carbon. And yeah. And then that's the high density, the 9550. With it, as I mentioned, you can get up to 2.4 petabytes with using high density drives, which you can reduce the footprint on your data center. Okay. And then also with the highlight of tiering, you have the flexibility of policies that you can set, where you can set temperatures onto your data. You can have your hot data, which will be sitting on your production side. That is the data which is frequently accessed. And with it, you can also have your warm data that is maybe on your data center B, and extend it to the cold data, where you can be using it for archiving the long-term retention. That helps to reduce the footprint on your data center, and also cut the cost when it comes to having your data on the production side. So you can set those policies. And now coming to reliability, also we're talking about replication. And with the replication, it can happen on the storage level, and that is also on your point-to-point using the unified storage foundation. So you can have the data replicated across different platforms, that is from your Ocean Pacific to other systems. All right. And then also coming back to the automatic migration of hot data, this is highlighting the tiering that is there, and you can move from high performance to the large capacity pool of your data, moving it across with ROC lossless network also included. Okay. And then one of the use cases also is being customer-centric with the powerful storage for scientific researches. And then with them, also you have your data sharing and analyzing services, and you can scale from the entry level of the 9920 Ocean Pacific 9920 to the 9950 to the 9550, and using all the capacity density drives to achieve the capacity needed, and you can save space with it. Okay, I think that should be me. Yes. Yes. Page 20. Yes. Which is it's on the hardware level. So with it, it comes to the processing to achieve all those IOPS. And from the hardware level, as we use active when it comes to the controllers. So you utilize 100% of your hardware instead of active passive or active standby. So this is where we achieve that performance. So for HPC, we have the Huawei self-made CPUs. One of it is Kopeng CPU. Yeah. So one of the controllers will have about 4 CPUs, and then in a deployment where you have, let's say, 4 nodes, you can now have up to that is 4 by 4, 16 CPUs. So yeah, mainly with it, the architecture on the background is active on the controllers instead of active standby. But yeah, I can share some of the hardware of it. Okay. All right. Thank you very much.
Thank you, Colin.